Our next section is mode of binomial distribution. What is meant by mode of a set of observations? In a set of observations, the most frequently occurring value is known as mode of the data. But in the terms of probability distribution, mode is the one value among the values realized by the random variable that has the maximum probability. So, if P of x is the probability distribution of a random variable x, the mode is the value of x at which probability becomes maximum. So, if x has values like x1, x2, etc., xn, at one of these values x1, x2, etc., xn, probability becomes maximum. At that point is known as mode of the distribution. Naturally, the most frequently occurring observation has maximum probability. In this way, we are going to determine the mode of binomial distribution. Now, suppose that the variable x has binomial distribution, that is x follows Bn. Therefore, its probability mass function is given by P of x equals n cx p raised to x q raised to n minus x, and x values are 0, 1, 2, etc. n. According to the concept of mode, we have one value of this 0, 1, etc. n with the maximum probability. We assume that at x0 the probability becomes maximum. That is, x0 is one of the values among 0, 1, etc. So P of x0 has to be maximum so that mode occurs at x0. Therefore, we consider that by two equations, P of x0 is greater than or equal to P of x0 plus 1 and P of x0 is greater than or equal to P of x0 minus 1. This means that preceding and succeeding values of x0 have lesser probabilities than the probability at x0. Therefore, the assumed mode x0 has the maximum probability. So, this concept is given by these two equations, P of x0 greater than or equal to P of x0 plus 1 and P of x0 greater than or equal to P of x0 minus 1. So, the assumed mode x0 is determined by solving these two equations. So for that, we consider the first equation P of x0 greater than or equal to P of x0 plus 1. Using the probability distribution, P of x0 is nc x0, p raised to x0, q raised to n minus x0, which is greater than or equal to the right side P of x0 plus 1. Its probability is obtained by putting x0 plus 1 in the general equation, that is nc x0 plus 1, p raised to x0 plus 1, q raised to n minus x0 minus 1. Now, this can be written as n factorial by x0 factorial, n minus x0 factorial, p raised to x0, q raised to n minus x0 greater than or equal to n factorial by x0 plus 1 factorial into n minus x0 minus 1 factorial into p raised to x0 plus 1 into q raised to n minus x0 minus 1. We can see a lot of similar terms on both sides of this integration. So we can cancel those similar terms. That is n factorials cancel. Now x0 factorial in left side, in the right side we have x0 plus 1 factorial. So the last term x0 plus 1 will be excess in the right side. The remaining terms can be written in the next step. So it is 1 by, here x0 factorial, other side x0 plus 1 factorial. So 1 x0 plus 1 is extra in the right side. So this x0 factorial. Here 1 to x0 factorial will be cancelled. So n minus x0 factorial here. In the other side it is n minus x0 minus 1 factorial. So n minus x0 will remain in the left side. and there is p raised to x0, in the opposite side p raised to x0 plus 1. So p raised to x0 will cancel each other. So here q raised to n minus x0, in the other side q raised to n minus x0 minus 1. So one q will remain in the left side, and the right side is 1 by this x0 plus 1, then p, then other p raised to x0s and q raised to n minus x0 minus 1 cancel. So this is the next step when we cancel the similar terms on both sides. Further, we can simplify this by cross multiplication. So q into x0 plus 1 is greater than or equal to p into n minus x0. That is, q can be considered as 1 minus p. So 1 minus p into x0 plus 1 greater than or equal to p into n minus x0. So now we open brackets on both sides. So this is x0 plus 1. Now 1 into this x0 plus 1 minus p x0 minus p greater than or equal to np minus px0. So when we cancel both minus px0 and minus px0 and keeping x0 only in one side, so it is x0 greater than or equal to, now np plus p minus 1, or which can be considered as n plus 1 into p minus 1. So if you write the reverse order, it becomes n plus 1 into p minus 1 less than or equal to x0. Thus, from the first equation, p of x0 greater than or equal to p of x0 plus 1, we get the simplified equation as n plus 1 into p minus 1 less than or equal to x0. Next, we simplify the second equation along the similar steps. So the left side will be exactly the same. The right side is probability at x0 minus 1. So this x0 plus 1 can be taken as x0 minus 1. And this is x0 minus 1. And this will be x0 plus 1 because of two negatives. So when we cancel, again rewriting the terms in using factorials, this is same as the previous simplification. And this will be n factorial. And here this will be x0 minus 1 factorial, and the next is n minus x0 plus 1 factorial, and second p raised to x0 minus 1 into q raised to n minus x0 plus 1. Okay, again we can cancel similar terms on the left and right sides of this equation. As before, n factorials will be cancelled. In the left side, this x factorial, x0 factorial, and the other side is x0 minus 1 factorial. So it's only 1 by x0 in the left side. This is n minus x0. The opposite side is n minus x0 plus 1. So it is greater than to 1 by n minus x0 plus 1. So the terms from 1 to n minus x0 will be cancelled. There is only the extra term n minus x0 plus 1. This is p raised to x0, but the opposite side p raised to x0 minus 1. So p will remain there. In the left side q raised to n minus x0, opposite side q raised to n minus x0 plus 1. So it is simply q1. So this can be simplified using the cancellation of similar terms on left and right sides. Now we can rewrite using cross multiplication. So this becomes n minus x0 plus 1 into p, now greater than or equal to 1 minus p, that is q, into x0. This q has been taken as 1 minus x0. So if you open the brackets, np minus px0 plus p greater than or equal to x0 minus px0. Again, we can cancel some of the similar terms and we can write the reverse order. So it becomes x0 less than or equal to np plus p, which can be considered as n plus 1 into p. Thus, the second equation has been simplified as x0 less than or equal to n plus 1 p. In short, from the first equation, we get n plus 1 into p minus 1 less than or equal to x0, and from second equation we get x0 less than or equal to n plus 1 into p. So if we combine these two equations, we see that the mode lies between n plus 1 into p minus 1 and n plus 1 into p. That is n plus 1 into p minus 1 less than or equal to x0 less than or equal to n plus 1 into p. So the mode is given by two limits, n plus 1 into p minus 1 and n plus 1 into p. See, we don't have an exact equation for mode in binomial distribution like mean. We have mean is equal to np. For the case of mode, we get only two limits within which mode will belong. Now we consider the case of the value of n plus 1 into p. See, n plus 1 into p may be a whole number or not a whole number. If n plus 1 into p is a whole number, definitely n plus 1 into p minus 1 also will be a whole number. Okay, we can see numerical examples of this n and p later. So when these two are whole numbers, mode of the binomial distribution are n plus 1 into p and n plus 1 into p minus 1. Because mode of binomial distribution has to be necessarily a whole number. Because as I told you earlier, this mode of binomial distribution is one among the 0 and etc. Yet, or it is some value of the variable where probability becomes highest. So it must be a whole number. So if n plus 1 into p is a whole number, n plus 1 into p minus 1 also a whole number, and that is a situation where binomial distribution has two modes. So if this n plus 1 into p is a whole number, we have two modes for binomial distribution, and we say that binomial distribution is bimodal. And some other situation, n plus 1 into p may be not a whole number. So naturally n plus 1 into p minus 1 also not a whole number. In that case, there is a unique whole number in between this n plus 1 into p minus 1 and n plus 1 into p. And that unique whole number is the mode of binomial distribution. Therefore, binomial distribution may be unimodal or bimodal according as the values of n and p. So we conclude that if n plus 1 into p is a whole number, the distribution has two modes at n plus 1 into p minus 1 and n plus 1 into p. And if n plus 1 into p is not a whole number, binomial distribution is a unimodal, and it is the whole number between n plus 1 p minus 1 and n plus 1 into p. Consider a random variable x following binomial distribution with the number of trials of 10 and the probability of success 1 by 3. So its equation of probabilities is p of x equals 10cx 1 by 3 raised to x and 2 by 3 raised to 10 minus x value 0, 1, 2, etc. 10. You can see that mode of this binomial distribution is one of the values are 1, 0 and etc. 10. And by definition, at this point, this probability will be highest. We found that mode of the binomial distribution lies between n plus 1 into p minus 1 and n plus 1 into p. So using this equation, we see that here mode will lie between 10 plus 1 into 1 by 3 minus 1 and 10 plus 1 into 1 by 3. This is 3.67 minus 1, that is 2.67, and the other side it is 3.67. So, the mode of the binomial distribution is the unique whole number that lies between 2.67 and 3.67. And you can see that it is 3. Therefore, in this case, mode of the binomial distribution is at x equal to 3. Later we can see that, or we can verify that at x equal to 3 only, the probability becomes maximum by putting values of x as 0, 1, 2, etc. in this equation. You can verify that at x equal to 3, the probability will be highest. So here we say the binomial distribution is unimodal because here at x equal to 3 only, the mode appears. Later, if this n is 11 and p is 1 by 3, you can see that binomial distribution 11, 1 by 3. The equation will be p of x equals 11 cx 1 by 3 raised to x, 2 by 3 raised to 11 minus x, and the values will go up to 11. So in this case, the limits are 11 plus 1 into 1 by 3 minus 1 and 11 plus 1 into 1 by 3. And that is 11 plus 1 into 1 by 3 is 3 and this is 4. So we say that this case binomial distribution has two modes. The two modes are at x equal to 3 and x equal to 4 because this x equal to 3 and x equal to 4 are the points where probability becomes highest, and therefore the distribution is said to be bimodal. So depending on the value of n and p, the distribution becomes unimodal or bimodal. When n plus 1 into p is a whole number, distribution will be bimodal with the modes at n plus 1 into p minus 1 and n plus 1 into p, and when the distribution will be unimodal when n plus 1 into p is not a whole number.